Alright, Bismillahirrahmanirrahim. Assalamualaikum. So today we're going to continue on our syllabus on organizing data and graphing on quantitative data set. Right. So as we know on earlier lecture, quantitative data is a numerical data. Right. It can be categorized into two types of quantitative data, either discrete quantitative data and continuous quantitative data. So quantitative data are normally summarized in tabular form, and we use frequency table to simplify the data. So normally we will get ungrouped data. So from this ungrouped data, we will use a frequency table to describe the data, a range of data, right, to simplify the data. So the quantitative data can be divided into two types. First is ungrouped data, another one is group data. So remember, we have two types of quantitative in this topic. We will dealing on ungrouped data, and we will also dealing with group data. So ungrouped data, so this is kind of example for ungrouped data, is data that is not in group, right? So it's a spread data. So we have 55, 44, 37, 50. So it's not in group data, right? It's a spread data. So data give information on each member of the population or sample individually lah. Right, let's look at group example for group data. So this is example for group data. Notice the difference of this frequency table and previous frequency table. Right, this is a quantitative data, group data. Right, so quantitative group data, we have same as qualitative data. The frequency table for qualitative data same as quantitative data. So this, the first column we have X, and then the second column we have frequency. Instead of we having a classification or category for each row, we have a range of number for each row, right? So this is a example for quantitative data. Let's look at the previous one. Previous one we have like this. This one. We have same presentation. We have X column and frequency column. Instead of each row, for each class, we have a classification category, right? Comedy, action, and romance. But for quantitative data, instead of having a category, we have a range of data from 0 to 10, 10 to 20, 20 to 30, and so on. And on the second column, we have a same value, which is frequency, right? So in the last row, we have a total for the whole frequency table. So this is example for group quantitative data. Right, let me introduce, before we go further, let me introduce the term that we use for group quantitative data frequency table. Right, so the first value here we call as a lower class limit. Lower class limit. Upper value here we call as upper class limit. If you notice here, the value of lower class limit and upper class limit for the first class is equal to the lower class limit of the second class. Right, if you can notice here, upper class limit for the first class is equal to the lower class limit for the second class. So instead of we call this as a class limit, this is also called as a upper class boundary. This is also what I call as a lower class boundary. So when to use this term, lower class limit, lower class boundary? So let's say another example. Let's say we have a frequency table for quantitative data. This is X and F. Let's say 0 to 9, 10 to 20, 19. Let's say, for example, 20 to 29, and 30 to 39, for example. Now, tengok dekat sini. If you can notice, upper class limit and for the first class is not equal to the lower class limit for the second class. So in this case, we are not calling this as a class boundary. This is still called as class limit, and this is also called as lower class limit. When upper class limit for the first class is equal to lower class limit for the second class, then baru kita kata this is a class boundary. Boleh faham? The term, I just introduced the term, right? So this one we call as first class. This is a second class, and so on lah. And the range here, let's say 40 to 50. So we have range daripada 40 to 50, right? So 50 minus 40 is equal to 10, right? So the range of this number, right? 10, this is what we call as class size. Take note of this term, right? This is what we call as class size, right? So the middle value, let's say I bawa ke tepi sikit. The middle value, let's say I have a frequency table. For example, this is X 0 to 10, 10 to 20, 20 to 30, 30 to 40, right? 40 to 50, so example. So the middle value, 0 plus 10 divided by 2. The middle value, this is what we call as, kita kata class, and then this is a midpoint. Midpoint, the middle value 10 plus 0 divided by 2, so kita akan dapat 5, right? 10 plus 20 plus 10 divided by 2, so we will get 15. This is 25, 35, 45, right? So the middle value the middle value is called as midpoint. The formula for midpoint is upper class boundary plus lower class boundary divided by 2. This is the formula to get midpoint. This is very important when you want to calculate a mean and standard deviation. Boleh faham, eh? So this is the term that we need to understand for a frequency table. Right? Let's move on to the next topic. So in displaying the frequency quantitative data as in qualitative data, we already know we can construct a bar chart, whether it's a vertical bar chart or horizontal bar chart, cluster bar chart or multiple bar chart. Another one, we can construct a stack bar chart or component bar chart, right? And another one is pie chart for qualitative data. For quantitative data, we can construct a stem and leaf plot. Stem and leaf plot is a widely used in exploratory data when the data set is small. Now, let's focus on the objective. For qualitative data, we construct a bar chart either vertical component baca or cluster baca, we want to see the highest frequency and the lowest frequency, right? We want to know what is the frequency of each class. But for quantitative data, what we want to know is, we want to know instead of the highest value and the lowest value, right? We want to know the shape of the distribution of the data. The shape distribution of the data, right? We want to know either the data is normally distributed, right? Normally distributed, dia bentuk macam bell shape, right? Dia macam ni. Another one is we want to know whether the data is skewed to the right distribution or skewed to the left distribution. Mana nak tahu? If the tail is longer to the right, so this is a skewed to the right distribution. If the tail is longer to the left, and this is what we call as skewed to the left distribution. If the tail are equally have equal length, right, on the right and left, so this is what we call as a normal distribution or symmetrical distribution. Please remember this term, right? So dekat sini dia dah bagi tahu dekat sini. Usually we interpret the stem and leaf plot in term of skewness. The skewness measure the lack of symmetry in the data distribution. So whether it's a normal distribution or skewed distribution. This is a skewed to the left, skewed to the right distribution. Right. So now this plot separate data into leading digits we call as stem, right? Leading digits called as stem and trailing digits called as leaf. It also allow us to show the range of data value and shape of data distribution lah. So how to construct a stem and leaf plot? So this is a step. First, we need to split each value into two set digit. First set digit called as stem and second set digit called as leaf. For example, let's look at this data, right? Group data on page number 54. Right, so we have 55, 54, 44, 37, and so on. So if you look at this data set, we only have a two-digit number. So we have two-digit number. So let's say we're going to, if we want to spread or separate the the digit. So let's say we take 65. So we split 6 and 5. So 6 going to be on stem and 5 going to be on leaf. So this one should be equal to 65. Boleh faham, eh? So this is how we split the data, right? So now this is the first step is we need to split the value into two set of digit, which is stem and leaf, right? Contoh tadi, 65 is equal to 6, 5. 6 going to be on stem and 5 going to be on leaf, right? And second step is we list all possible stem and stem digit from the lowest to the highest. So this is the important part. We need to list down all the stem digit from the lowest to the highest. And for each value in mass data, write down the leaf number on the line labeled by appropriate stem number. Right, nanti I tunjuk kat you, okay. Right, so now look at page number 56. So this is how we construct the stem and leaf. We just need to know. This we have a ungroup data. This is a ungroup data. First, we need to arrange data in ascending order. So senang kita nak nampak, right? We arrange data in ascending order from the smallest value to the highest value, right? Now, next step, we split the data. We choose, let's say kita tengok sini semua ni, we have only two digits. So we choose, let's say 47 should be equal to 4/7. 4 is a stem, 7 going to be on leaf. Right? So we list down, let's say I buat daripada mula lah, senang you nampak kan, stem, leaf. Right? So the first leading digit is 1. Second, 2. And then kita ada 3, 3 and 4. Right? And then we need to write down the value for leaf digit. So this is going to be 5, 6 and 20 kita ada sampai 26. So 1, 3, 3, 6 and 6. And kita tengok pula yang untuk 30 we have 0 and 2. And 40 we have 1 and 7. So this is what we call as stem and leaf plot. Right? Stem and leaf plot. So how to read stem and leaf plot? So kita ambil ni, let's say how to rotate this one. Rotate. Yep. This is how we read the stem and leaf plot. So I nak tunjuk sini. Right. So kita rotate we rotate the plot, right? So make sure the smallest value on the left hand side and the largest value on the right hand side, right? So daripada sini kita boleh nampak the shape of distribution, right? Whether this is skewed to the right or skewed to normally distributed. Kalau kita bandingkan, right, on the shape or distribution yang kita belajar tadi. So if you're skewed to the right and the tail is longer to the right. So kita nampak dekat sini, the tail is a bit longer to the right. It's actually skewed to slightly skewed to the right distribution. This is very small small data, so you cannot see the actual shape lah. So then you need to put some notes so the reader can understand the term that you use. 1/5 means 15. Right, so kalau you biar macam ni, reader will not understand what is the meaning of this graph. So you need to put some note. 1/5 is equal to 15. So this is what how we construct a stem and leaf diagram. Alright. Okay. So let's move to the next graph, which is frequency distribution for ungrouped data. We will cover for group data and ungrouped data. Right. So if we have a frequency table, if we have ungrouped data, so the one of the best way to present the data in to read the data is by using frequency table, right? So to use frequency table for ungrouped data, we need to classify the data into a group, right? So let's say we have set of data. This is 1, 2, 3, 4, 5, 6. We have 12 n equal to 12, right? So we need to partition this data into a group, right? So how to partition this data into a group, right? So we're going to use some step, which is first we need to know how to determine number of class. So we need to know how many number of class that we want to construct. So let's say kita nampak kat sini dia dah construct 1, 2, 3, 4. Right? So from this data, we want to transform it to a frequency table. Right? Okay? So first, we want to know how many class that we want to construct. Second, what is the class size that we want to use. And then the step number 3, we will construct the graph lah. So to determine number of class, we will use Sturge rule. Sturge rule, S-T-U-R-G-E, Sturge rule. Sturge rule formula, which is 1 plus 3.3 log 10n. So this is how we find k, which is number of class. Oh, sorry, k is number of card. So let's say we have 12, number is kat sini 12, so 1 plus 3.3 log 10, 12. So kita akan dapat berapa ni? Tekan calculator, log 12 kali dengan 3.3 tambah 1. So we will get 4.56. Basically, kita akan round down lah. So round down should be equal to 4, right? So we will create 4 class from this number, from this group, ungroup data. Okay, let's look at the frequency distribution of group data. This is the on page number 58 ni, I already explained step by step. So how we going to construct the group frequency table from ungroup data, right? So okay, this one. Okay, kita tengok. So this one I already explained to you, right? But in your class, you no need to know. You don't need to construct a frequency table, but you just need to know, right? To construct a frequency table from ungroup data, so first we need to find how many class that we want to construct. So to find number of class, we use search rule, 1 plus 3.3 log n. You just need to know that. And then, what is the class size? So class size, mana dapat class size? The formula for class size is the largest value minus smallest value divided by k. So this is how we find class size. Alright, boleh faham? Very simple. Tak pening kepala pun, you don't need to construct the frequency table, right? Because our aim is to learn how to know there is a way to construct a frequency table from ungroup data, and we need to know this step lah. We don't need to construct, we just need to know this step, and of course this is going to be in your test, right? So for page number 58, I already explained earlier, right? So class size is the upper class size minus lower class boundary. Midpoint upper class limit plus lower class limit divided by 2 is also same as upper class boundary plus lower class boundary divided by 2. And class size, as I mentioned earlier, largest data value minus smallest data value, which is range, divided by number of class. So there are two formula in page number 59. I already put the formula number 1. This is formula number 2. We can choose either one, but I am prefer to use search rule. Search rule, right? So another formula you can use is log n divided by log 2, right? So this is an example of frequency table without class boundary. Right, as I explained earlier lah. So without class boundary means that upper class boundary of the first class is not equal to lower class boundary of the second class. And the frequency table with class boundary means upper class boundary of the first class is equal to lower class boundary of the second class. Then another frequency table, we have a less than method. 18 less than 23, 23 less than 28. So this is another method of presenting a frequency table for group data. And we also have open-ended class, which is 18 to make it blank, and 23 make it blank, and so on. So this is what we call as 18 more than 18 but less than 23 for the first class. Another example for frequency table by using 2, 401 to 600, 601 to 800. So this is another method, right? Okay, so you just need to know how to construct a frequency table from ungrouped data, right? You don't need to construct in this subject, we just need to know, right? First, we need to determine number of class. So to determine number of class by using sturge rule or log n divided by log n divided by log 2, right? You can use another one, but I strongly suggest you to remember sturge rule, right? 1 plus 3.3 log n, log 10n, base n, right? And then once you already determine the number of class, and then you need to determine the class size. So the class size is the largest data value minus smallest data value divided by k. Right, so this is a formula. You just need to remember and know. That's all. No need to construct. Senang hidup you kan? Senang kan? Alright, now let's look at the next graph that we can use for quantitative data. The famous graph for quantitative data is a histogram. So histogram is a graphical display of data using bar of different height, right? So as it's the same as a bar chart, but in histogram, if you remember bar chart, when you construct histogram bar chart, y-axis is your frequency, right? X-axis is your category or class, right? Remember bar chart? So we start with some space, baru kita buat satu bar, the first bar. For the second bar, we leave some space, we construct the second bar. So this is for bar chart, right? For qualitative data. For qualitative data. But for histogram, we have y-axis and x-axis as well, right? So y-axis represent frequency, x-axis represent class boundary. Class boundary. So if you can look at this example number 12, we have a frequency table for quantitative data. This is the lower class limit. This is upper class limit, right? It's not a class boundary because upper class limit for the first class is not equal to lower class limit for the second class. So now what we need to do is to create a class boundary. So we need to create a class boundary. This is a class boundary. So let's look at the upper class limit for the first class and lower class limit for the second class. To create a class boundary, so 24 plus 25 divide by 2. So you will get to 24.5. And the second row, the second class would start from 24.5 and so on. 34.5, 34.5, this is 44.5, 44.5 until 54.5. This is 54.5, 64.5, 74.5, and the last one is 74.5 until 84.5. How do we know 84.5? It's based on the trend, right? Sebab kita tambah 0.5 saja, right? So we need to put 84.5. For the lower class limit, for the first class, kita tengok dekat sini 25, it become 24.5. We minus 0.5, so it become 15.5, 0.5, right? Okay. To construct a histogram, as we know, the x-axis is your class boundary. Listen carefully, this is very important. So to create the first bar, right? So we leave some space. The first bar kat sini, it should be 15.5, and then 24.5, 34.5, and then this is 44.5, 54.5, and so on lah. So it should represent a class boundary. It start from 15.5 until 84.5 lah. Let me erase this one. Kita buat sampai habis, nanti confuse. Right. So this is 54.5, and then 64.5, 74.5, 84.5. So this is represent class boundary, ataupun dekat sini kita kata age lah, right? The value, and this is a frequency, means that student kan, right? So the first bar will represent the frequency. So let's say this is 2, 4, 8, 10, 2, 4, 8 pula dah. 2, 4, 6, 8. Two, 4, 6, 8, 10, 12, let's say sampai atas lah. So now, I tak syok kalau tak habis. Sekejap copy this one. Turun bawah sikit. Alright. So 12, 14, 16. So this is a frequency, right? So the first bar is 2. So you garis 2 lah, right? So for histogram, there are no space between the first bar and the second bar. There no space. Maksudnya combine lah. So the second bar is 10. So you highlight 10. You mesti rapat-rapat, right? And then 15. So tengah-tengah ni, right? 15. So you should draw this in a graph paper. Nanti dah habis kelas, you try on graph paper. Right? This is 9. And this is 3 atas sikit. Alright. And this is 4. Right? And as we know, nampak tak cantik lah. Memang tak cantik pun. But you need to draw in graph paper baru nampak cantik. And make sure you scale this class boundary properly lah. So this one, dia punya gap 10. So maksudnya dalam 10 kotak you kena buat. And then don't forget the title for histogram. Histogram showing apa? Number of student by age. Contoh, right? So this is histogram. Dah siap. Okay. So the shape. What is the objective of doing histogram? Same as stem and leaf. We want to know the shape of distribution, right? So if you look at this histogram, we already know this is a skewed to the right distribution. Okay. Now let's look at a frequency polygon. Frequency polygon is a graph that is formed by joining the midpoint of each class on histogram, right? So histogram ni, let's say tadi I buat ni, padam ni dulu. So to construct a frequency polygon, let's say I use a green color. So kita akan ambil the midpoint. So this is like a midpoint of the top of the bar in histogram. Kita ambil midpoint and we join the midpoint by ruler lah. We join the midpoint. So it's the same objective. We just want to know the shape of distribution. So if you look at this one, we know that this is a skew to the right distribution. Okay. So I just want to touch this and let you know what is the objective and how to construct. You don't need to construct, but it's a good practice. Have a time to construct in graph paper. right? Okay, before we go for cumulative frequency distribution, I think kita rest 5 minit. Okay, alright, kita continue, right? Cumulative frequency distribution. So I think this one already explained in earlier lecture, right? On the previous lecture actually, right? There are two types of cumulative frequency distribution. We have a less than method and more than method. But this is for less than is a frequently used compared to more than, right? So we only in this subject we only focus on less than method. For example, let's say we have a frequency table. So let's say we have, this is a class from 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50, and the total here. Right, let's say this is example of frequency table for quantitative data, right? And then we have a frequency value. Let's say we have 5 here, and then we have another 4, 3, and then we have let's say 10. This is 5 again. So the total here should be berapa? 9 plus 3, 9, 10, 5, 27. 27, right? So cumulative frequency, we need to create another column called as cumulative frequency, right? For frequency, the symbol for frequency is small letter f. For cumulative frequency is capital letter F, right? Cumulative frequency start from before the first class. Before the first class, we don't have any frequency, and the class is not exist, right? So cumulative frequency of the first class is, let me use, right? Cumulative frequency before the first class plus frequency of the second class is equal to cumulative frequency of the first class. This one should be 5. 5 plus 4 should be equal to 9. 9 plus 3, 12. 12 plus 10, 22. 22 plus 5 is 27. And the last value, cumulative frequency, should equal to the total frequency, which is summation of F. Right? And relative frequency also I already explained earlier. So to construct a relative frequency, right? Relative frequency also known as probability of the class, right? So let's say we create another column just to explain to you, and this is a very important things to know, right? Relative frequency, or what we call as probability class column. Relative frequency, this is a relative frequency, right? Relative frequency is frequency of the class divided by total value of the frequency, right? So 5 divided by 27, it should get 0.18. 185 lah, 185. Kita ambil 3 decimal point here. And then 4 divided by 27, and so on. So 0.148. And the last value, right, means that when you already calculate the relative frequency, the total of relative frequency should always equal to 1. Always equal to 1. It cannot be less than 1. It cannot be more than 1. This is what we call a relative frequency. Okay. This one I think I already explained in previous lecture, right? So let's move to the next type of graph, which is this in page number 64. I already show you how to calculate cumulative frequency, relative frequency, and cumulative relative frequency. Right? Cumulative relative frequency is the same concept of cumulative frequency, where on cumulative relative frequency, we just take a cumulative on relative frequency. Right? Let's look at Ogive or cumulative frequency curve. So Ogive is a graph or line chart of a cumulative frequency distribution. It's a S-shaped distribution. S-shaped distribution maksudnya dia akan bentuk S lah. Contoh, let's say we have this one, dia akan bentuk macam ni. Alright. S-shape. Right. This is what we call as a Ogive or cumulative relative distribution. So dekat sini kita boleh baca a less than Ogive. We only focus on less than frequency distribution kan. Is an increasing function and it rise from to the right. So dia akan meninggi ke kanan. On the other hand, a more than Ogive is the decreasing function. It fall to the right. So we're not focusing on more than Ogive lah. Tapi what we need to know, there is a graph for more than Ogive. So Ogive is drawn based on the data from a cumulative frequency table or data from cumulative relative frequency lah. But we only focus on cumulative frequency. Let's say we have a frequency table for quantitative data from 1 to 4, 5 to 8, 9 to 12, and so on. If you look at the class range, upper class boundary, so upper class limit for the first class, right, is 4. Is not equal to the lower class limit of the second class. So this is not in form of class boundary. So in Ogive, x-axis will represent a class boundary, right? Where in y-axis will represent a cumulative frequency, capital F. Right? As compared to histogram, y-axis represent frequency, x-axis represent class boundary. But for Ogive, y-axis represent a cumulative frequency and x-axis represent class boundary. Right? Very simple, easy to remember. So now we need to find the class boundary, right? So if you look at this one, okay, tak apa dia tak tulis, kita buat. I just nak tunjuk dekat you. This is from 0.5 to 4.5, 4.5 to 8.5, 8.5 to 12.5, 12.5 to 16.5, to 20.5, 20.5 to 24.5, 24.5 to 28.5. How do I get 0.5 ni? Macam mana dapat? 4 plus 5 divided by 2. Right? 20 plus 21 divided by 2. Sama, the same method as I explained earlier. So this is what we call as a class boundary. Right? This is what we call as class boundary. And to draw in less than Ogive, we start from 0.5. The origin should be equal to 0.5, 4.5, 8.5, this is 12.5, and then we have 16.5, 20.5, and then kita ada lagi 24.5, and the last one is 28.5. This is a class boundary, right? And we have a cumulative frequency. So kita kena create a new column, which is what we call as a cumulative frequency, capital F. So this one should be, this is 16, 36, 36 plus 28 should be equal to 64 plus 24, 88 plus 16, 104 plus 11, 115 and 120. Right. So let's say kita buat 10. So kita scalekan betul-betul dalam graf 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So this is a cumulative frequency. So kita tengok cumulative frequency. We only focus on cumulative frequency. Right? We focus on cumulative frequency only. So the first point should be, let's say, right. So first point is, remember, cumulative frequency start before the first class, right? Before the first class is the value is 0, kan? So 0.5 is 0. 4.5 is 16. So kita letak 16 kat sini. Okay, 16, right? And then we have 8.5, we have 36, so we tanda 36, and then 64, tanda 64, right? And then we have 88, tanda 88, right? 64, somewhere here lah. You kena tanda betul-betul lah, I tanda tanpa menggunakan graph paper. So, you akan dapat a bit sengit sikit lah. And then 104 somewhere here. 115. And the last one is 120 lah. So, dia akan nampak bentuk S. But, kalau you tengok dekat sini tak nampak bentuk S, right? So, basically dia akan nampak bentuk S kalau you guna frequency graph paper betul-betul. Right? So, this is what we call as ogive, right? But this is not accurate lah because I'm drawing a freehand. So if you are doing on a graph paper, you akan supposedly you akan nampak bentuk macam ni lah. Dia akan bentuk macam ni, right? And the best way to draw less than ogive, you need to have a flexible ruler, right? So you can graph it properly, right? So why we need to draft it properly? Because when we do when the question asks you to find median, right, from a less than ogive, then you need to scale dalam graph paper lah, right? So this is how we draw a less than ogive, right? All of a step already mentioned in this book. Okay, boleh. So we finish graphing and data organizing for quantitative data. Do you have any question before we move to the next topic?
No, sir. Tak ada, sir.
Tak ada, eh? Alright, good. So if you don't have question, then suppose kita rehat 5 minit dulu, and then kita akan jumpa balik 10:07 minit. Alright, just now we already look at the different part of displaying data and organizing data, right? So now this is a second part of chapter number 1, which is measure of central tendency, which is we want to know the descriptive statistics, right? So let's look at the scheme of work. In scheme of work, we already cover type of statistics. We already know the variable types of data, level of measurement. We already learned in a previous lecture, data collection method and sampling techniques. Organizing data such as bar chart, pie chart, we already look into for qualitative data. For quantitative data, we already look at the stem and leaf, histogram, frequency, polygon, or GIF. Right. Now, for second part is we want to know the data description. This is still under topic number 1. Right. So under this data description, we will look into group data and ungrouped data. Right. So we will cover measure for central tendency, measure of dispersion, coefficient of variation, and the skewness of the data distribution. And you need to remember, for descriptive statistics, or data description, this is only possible when we have a quantitative data. If you have a qualitative data, we cannot find mean and median. We only can find mode, right? So now let's look at measure of central tendency. Under measure of central tendency, we will learn mean, median, and mode. Right? Mean is the average of the data values. Right? So the formula for mean for ungrouped data is summation of x divided by n. This is for ungrouped data. For group data, summation of fx divided by summation of f. F means frequency, right? Summation of fx divided by summation of f. And you need to remember, summation of fx is not equal to summation of f multiplied with summation of x. It's not the same formula, right? So summation of fx means that you need to multiply frequency and the midpoint, and x here will represent the midpoint of the frequency table. If the frequency table don't have if the frequency table have a range of the value. If the frequency table don't have any range of the value, then this x is going to be the class value lah, right? So for median is the middle value of the data, right? Median is the middle value of the arranged data in ascending order. Means that you need to arrange data in ascending order, then you find the value of median. Listen, now you need to listen first. Later on we will do some example. I just want to explain to you what is the meaning of mean, median, and mode, standard deviation, and variance. First, we need to find the location of median. So to find the location of median by using this formula, n plus 1 divided by 2. So remember, in the first column here is for ungrouped data, right? What I explain here now is for ungrouped data. So there are 3 steps in finding median for ungrouped data. Let's say we have 10, 20, 25, 30, 35, and 40, for example. This is the arranged data. So I already arranged from the lowest value to the highest value. So first, this is the first step. Second step, to find median for ungrouped data, we need to find location for median. Before I forgot, the symbol for mean is X bar. This is a symbol for sample mean, right? For symbol for median is X tilde, right? So this is a symbol for sample median. So second step is we need to find the location of median, which is n plus 1 divided by 2. So n is how many value we have? 1, 2, 3, 4, 5, 6. So 6 plus 1 divided by 2, which is equal to 7 over 2, equal to 3.5. So the best way to before we start calculating the value of median, on the first step, when we already arrange data in ascending order, right? We need to position the value. This is position number 1, 2, 3, 4, 5, and 6. Right? So this is important part. If you're not listening to this lecture, I don't think you can get it. Right? I don't think you can get it. When you're not listening to this lecture, you're not paying attention, I don't think you can get it. So this is position number 1, position number 2, 3, 4, and 5, 6. So this is the location of median by using n plus 1 divided by 2. So you will get 3.5. So 3.5 means that the value of median is in the position of 3.5. So kita tengok dekat sini, this is position number 1, 2, 3, 4. So 3.5 is somewhere in the middle between 25 and 30. So step number 3, we need to find the value of median, which is how to get 3.5? 4 plus 3 divided by 2. We will get 3.5, right? So by using that concept, we take 30 plus 25 divided by 2. So you will get berapa? Dengar tak? Ke jauh? Sorry, my microphone taruh bawah. Right? So 25 plus 30 divided by 2. So you will get 27.5. So this is the value of median for ungrouped data. Right? So for group data, right? So this is the formula for group data. Lower class boundary of the median class plus n plus 2 means that total frequency ataupun summation of f divided by 2. So you need to change the formula dekat sini, right? Instead of n divided by 2, you change it to summation of f divided by 2. Can you do that? Summation of f divided by 2 minus cumulative frequency before the median class divided by frequency of the median class multiply with the class size of the median class. So this is the formula to find median from group data. Later on we will see the example, okay? So let's look at the mode, the definition of mode. Mode is the most frequent value in the data set, right? Mode is the most frequent value in the data set. So when we have a frequency ungrouped data, right, nanti kita tengok when we have ungrouped data, so kita tengok number yang muncul banyak kali, that is our mode, right? When we have a group data, we need to use this formula. So lower class boundary of the model class plus frequency before the model class, frequency of the model class minus frequency, frequency of the model class minus frequency before the model class, divide by frequency of the model class minus frequency before and frequency before the model class minus frequency after the model class. Kejap I tengok the formula, make it simple for you so you can understand. This formula is quite confusing. Yeah. Okay. F0 means that frequency of the model class. F1 frequency before model class. F2 frequency after model class, right? So F0 means that frequency of the model class minus frequency before the model class. Ini sama, benda yang sama dekat bawah ni dengan atas ni. F0 minus F2 means that frequency of the model class minus frequency after the model class. And then you need to multiply with C. So this one patutnya dekat atas lah, kat sini ha. C is the class size of the model class. Boleh faham eh? Alright, I hope you understand. Okay. Again, if you're not paying attention for this, and I will not sure you can get it, right? I will not sure you can understand this concept, right? And then when you apply the formula, you will get the value of mode, right? Later on, we will see the how to calculate mean, mode, median. Now, let's look at the formula for standard deviation and variance, right? So, now why we need standard deviation? So, let's say I have a data that I collect from a playground, for example, kan? Let's say I have n1 equal to 10. The second playground is n2 also equal to 10. Let's say I go to the playground, I measure the children age at the playground. So I will get the mean for x1 equal to, let's say, 4. Let's say mean for playground number 2 also equal to 4. Based on these statistics, can we say these two distributions are equal? No, because we cannot make a conclusion yet, because we need to have the spread of the value, means the variance or standard deviation. So let's say we have this kind of distribution for playground A, right? For playground B, I have this type of distribution. So both have mean equal to 4. This is also have mean equal to 4. So obviously you can see the shape of data is not equal, because the first distribution we have a wide distribution, and the second distribution we have a less wide distribution. Dekat sini kalau kita tengok, the data is spread around the mean, right? And this data also spread around the mean. But kita tengok dekat sini, the minimum value and the maximum value are different compared to this data, right? So that's why we need to have a standard deviation to know the difference between these two distribution, right? So for ungrouped data, for standard deviation, the symbol for standard deviation is S, variance is S squared, right? Let's focus on ungrouped data. Ungrouped data, kalau you nampak the formula for ungrouped data, so 1 divided by n minus 1, right? Multiply with summation of x square minus summation of x, then u squared. Now you need to remember, summation of x square is not equal to summation of x and then u squared, right? It's a different value, and you divide by n, and taking a square root for standard deviation, right? It's the same value lah. So you need to know s is equal to square root of s squared. So you pandai dapat s lah. So for group data, 1 over x n basically you need to change this one to summation of f, right? Change to summation of f, right? Change the formula. Instead of n minus 1, it should be summation of f minus 1, right? So the formula should be 1 divided by f, summation of f divided minus 1, multiply with summation of fx square minus summation of fx, then you squared divided by this is summation of f, right? So you need to change this formula. So if you can see the note here, summation of fx squared is not equal to summation of fx and e squared. It's a totally different value, right? This is I just want to introduce you the formula. Now, later we will see how to calculate the value of variance, mean and standard deviation. Right, are you okay? Dah? Sudah? Sudah ke? Alright, good. Now, let's look at the characteristic of measure or dispersion. Right. The more spread out or dispersed the data are, the larger will be the range and interquarter range, the quarter deviation, the variance and standard deviation. So when you have a larger value of standard deviation or variance, it means that the value are widely spread around the mean. So kalau kita tengok dekat sini, data yang I tunjuk dekat sini, right? So if you can see here, data yang ada kat sini, right, are widely spread around the mean. So means that what we can expect here, we're going to expect the larger standard deviation and larger variance compared to this distribution. This distribution have a consistent or less spread around the mean. So this we're going to expect S to be small compared to the distribution number 1, right? So that is the importance of standard deviation and variance, right? So dia kata kat sini lagi, the more clustered the data, the smaller will be standard deviation and variance or range or interquarter range. Right, so but interquarter range semua kita tak belajar dalam subjek ni. We just focus on mean, mode, median, variance and deviation. Right, if all the value are same, that is there are no variation in the data. So kalau semua standard deviation equal to 0, it means that on our data we have only same value. Maksudnya, let's say kita ada 5 data, so 5 data mempunyai value yang sama. Let's say 20, 20, 20, 20. So the standard deviation should equal to 0. Right? So if you have a more same data, so the standard deviation will be smaller lah, right? Or equal to 0. And the last characteristic of measure or dispersion, standard deviation range can never be negative. It only can take positive value, right? So on page number 73, if you you tak beli calculator ES, you can use this step lah. Alright, let's look at a measure of skewness. Measure of skewness is a lack of symmetry in the data distribution. Distribution is symmetric if it look the same to the left and right on the center point. Maksudnya tadi I dah tunjuk dekat you, kalau dia normally distributed or symmetrical distributed, right? So dia akan bentuk macam ni lah. You akan nampak dia seolah-olah bell shape. So you know bell shape, bell yang lama tu, and dalam church, dalam movie kan, orang tarik bell kan, dia lebih kurang bentuk macam tu lah. So means that dekat bawah ni, the tail dekat sini can never touch the axis. So dia adalah asymptotic. Maksudnya it will go until negative infinity to infinity without touching the x-axis. And dekat sini kita akan dapat mean. Let's say this is the mean. Area on the left hand side is equal to area on the right hand side. Right? So this is a symmetrical distribution. For positive distribution or skewed to the right distribution, so we have this type of shape or distribution. Right? Kita nampak the tail is longer to the right, means that it's skewed to the right. right? If the tail is longer to left, right? Scale is longer to left, it means that skewed to the left. Skewed to the left distribution, skewed to the right distribution, right? So I hope you understand the shape of distribution. We will use this throughout this subject, right? And this is what we call as symmetric distribution or normal distribution, right? Later on the next topic, right, I will use the term normal distribution to indicate this type of distribution, right? Okay. So now, to measure skewness, right? So we have two formula. So first, you can use either formula, right? So the first formula is mean minus mode divided by standard deviation. And tadi I lupa nak introduce the symbol for mode. The symbol for mode is x hat. Right? Mean is x bar, median is x tilde. Right? So you can use either formula. This is the first formula, this is the second formula, right? So if you are using the first formula, mean minus mode divided by standard deviation. For the second formula, mean minus median multiply with 3, right? Divided by standard deviation. Either one you can use. So if the value of skewness, right, or this is what we call as coefficient of skewness, ataupun Pearson coefficient of skewness. This is developed by Carl Pearson. Right? If the value of Pearson coefficient of skewness equal to 0, right? Skewness equal to 0 means that it's a normally distributed distribution. If the skewness equal to negative value, any negative value, right, is actually skewed to the left distribution. If the skewness value equal to positive value, is actually skewed to the right distribution. Remember this. This is very important. We will use this concept, mean, mode, median, variance, standard deviation throughout this subject. And in fact, in your subject topic number 3, number 4, we will recalculate the mean and standard deviation. We will talk about mean and standard deviation all the time. Right? So this is the skewness. How to calculate skewness? If the skewness value equal to 0, means it's normally distributed. If the skewness value is equal to negative value, is skewed to the left. Skewness value positive, skewed to the right distribution. Right? Okay. This is the relationship of mean, mode, median. Right? So now, let's look at this one. This table. This graph, let's say kita tunjuk normal distribution, right? So if the data is normally distributed, the value of mean, the value of mode, the value of median are all equal. If mean equal to mode equal to median, then the data is normally distributed, right? So contoh tadi. Right, so daripada sini there's negative infinity to infinity lah, right? Let's look at when we have a skewed to the right distribution, right? Contoh, right? So this is negative infinity to infinity, and this is our mode, this is mean, and this is median. When the value of mode is smaller than mean, smaller than median, means that the value of median is larger compared to mean, mean also larger than mode. So then we can say that the distribution is skewed to the right distribution. If the value of, let's say this from negative infinity to infinity, this is mode, mean, and this is median. If the value of median is smaller than value of mean, smaller than value of mode, means that the value of mode is bigger compared to mean, and value of mean is bigger than median, then we can say that the distribution is skewed to the left distribution. Right? So I already note in this book, page number 76. Okay? Boleh? Let's move to the last topic in this chapter, coefficient of variation. Coefficient of variation is used to compare the dispersion or spread or variability of two or more data distribution. As I said before, let's say I have distribution A and distribution B, right? Macam contoh tadi, I have n equal to 10, x bar equal to 4, n equal to 10, x bar equal to 4. Let's say standard deviation for A, this is A, and this is B, sorry, B, as B. So let's say this standard deviation for A is equal to 2, and standard deviation for B is equal to 1. Right? And then kita dapat tadi, distribution dia macam ni. Right? Besar sikit, and distribution dia kat sini, sedikit kecil. Right? So, if you want to know which distribution has less dispersed or more dispersed, we can use the value of coefficient of variation, COV or CV. Right? Coefficient of variation is equal to standard deviation divided by mean, multiplied with 100%. Right? So it always expressed in the value into percentage. Right? Let's say for this example, CVA equal to 2 divided by 4 multiplied with 100%. So you will get 1 over 2, 50%. And CVB is equal to 1 over 4 multiplied with 100%. So you will get 25%. So which value is smaller? Of course, the distribution B is smaller. So we can say that distribution B is less spread or consistent compared to distribution A. That's the point. We want to see which distribution is more consistent or less spread compared to other distribution. Okay? If you can look at this graph, kalau graph ni lebih besar means that there more variability, kecil sikit less variability. There is a term called platycrutic and lepicrutics. Right? So now let's look at example. Right? You can look at your this example in page number 78, but I'm not going to go through this example because I already give you the answer. You can look it by yourself. Like look at the final exam question. Right. This is example of final exam question. I think last two semester before COVID, right? Right. Boleh nampak? You can write down. Kejap. Right. Time taken by machine X to assemble computer component in 100 motherboards are recorded below. Right. So the average time taken to assemble the computer component of 100 motherboard is 17.05. So they already tell you the mean for this data is 17.05. It's already tell you the mean of this data is 17.05, and this is the frequency. If you look at the frequency table, we don't have a class boundary, right? We don't have a class boundary. Just take note, right? We have a frequency value, and this is the value of the calculated from this frequency. So we have the total frequency is 100, means that the total here should be equal to 100, and fx equals 1705. Fx square is 32,345. So now they ask us to find the value of mode time, they calculate the mode of time taken and interpret its meaning. Now, to calculate mode, tadi kita tengok kan, to calculate mode, first we need to look at the data. We have a group data which with a range value in the class, right? So let's look at the formula for mode in page number 70, I think, 69. So lower class boundary of the model class plus the difference of model frequency before frequency of the model class and before model class, and plus different frequency before frequency of model class and before model class, frequency of the model class and after model class, multiply with class size. So let's look at the question again. So now, first step, we need to find a model class. Model class is the class that have the highest frequency. Remember, tadi I tak tunjuk, ni I nak tunjuk ni. Tengok, listen carefully. Model class is the class that has highest frequency. So based on this class, this table, which class has the highest frequency? Kelas mana yang ada highest frequency?
46.
46, right? This is the highest value of frequency, and this is the model class, right? We highlight the model class. So this is the model class. And before we start, kita take down the formula plus theta 1 divided by theta 1 plus theta 2 multiply with class size. So this is the formula, right? So lower class boundary of the model class. So now dalam class ni dia tak bagi class boundary. So how to calculate class boundary? So 14 plus 15 divided by 2. So we will get lower class boundary is 15.5 until 19.5. So the value of mode here, kita letak kat sini, 15.5 plus, because LM represent the lower class boundary of the model class. Right? And then multiply with theta 1. Yes.
Bukan 14.5.
Oh, sorry, 14.5, sorry. Yeah, very good. 14.5. Right, 14.5. Okay, this is the class, model class. Right. So next, theta 1. Theta 1 is the frequency of the model class minus frequency before the model class. Means that 46 minus 20. And divide by this denominator, start with theta 1 juga. 46 minus 20 plus theta 2 means that frequency of the model class minus frequency after the model class. 46 minus 15. Right? Susah betul. Dia tak nak pergi tepi. Okay, I think nampak kat sini kot. Alright. So we need to multiply with C. C is our class size. So class size mana dapat? Upper class boundary minus lower class boundary. So 19.5 minus 14.5. So calculate this one. So this one should be 14.5 plus 46 minus 20 is 26 divided by 26 plus 46 minus 15, 31, and multiply with 19.5 minus 14.5. So it should be equal to 5. And then masuk dalam calculator, you will get the answer. What is the answer? So what is the answer? It should be 16.78. Yeah. And you need to remember the value here should be within this range. 15 to 19. Kalau you dapat lebih atau kurang means you salah calculate lah. Right? So the value of mode is 16.778. And how to interpret? The largest time taken to assemble a computer is 16.7. Sorry, the most time taken to assemble a computer component is 16.78 minutes. Right?
Sir,
Yeah.
for frequency of the model class, dia ada state kat sini 17.05 minutes. Kita kena ambil yang range yang tu.
Mana? 17.05.
This is frequency of model class. Macam mana nak cari frequency of model class?
Oh,
sebab dia ada 17.05.
17.05. No. 17.05 is our mean. Sebab dia sebut kat sini average. Right? To find a model class, we need to find the class that has the highest frequency.
Oh, highest frequency.
Yes.
Frequency of model class.
Yes. The highest frequency. So 46 is the highest frequency then. So this is our model class.
Alright.
Right? Okay? Now, for the next question, calculate the standard deviation and of the time taken to assemble the computer components. Right? So the formula for standard deviation is summation of f(x) square minus summation of f(x) and then u square divided by summation of f and everything divided by summation of f minus 1 and taking a square root. So this is the formula for standard deviation. So I think they already give you the value of summation of f, summation of fx, summation of fx square. So now your task is very easy, right? It means that it's only 2 marks. Masukkan the value dalam formula lah. So summation of fx square is 32,345 minus 1705 and then squared divide by divide dekat sini 100 and everything divide by 100 minus 1 taking a square root. So you will get berapa? Cuba kira. Masuk dalam calculator kira 1705 squared divided by 100 and 32345 minus answer divided by 99 and taking the square root of answer, it should be 5.75. Boleh So now, number 3, determine the shape of distribution by using Pearson measure of skewness. Now, this is that you need to think which formula to use. Remember tadi we have two formula, right? I think, let me use this color. SK1, we have mean minus mode, right? We have mean minus mode divided by standard deviation. Another formula is 3 mean minus median divided by standard deviation. This is the second formula, if you still remember. Tengok balik buku, muka surat berapa. Yep. Still remember? We have two formula, mean minus mode divided by standard deviation, or mean minus median multiply with 3 divided by standard deviation. Right? So, now, to choose which formula to use, kita tengok balik apa yang dia tanya soalan sebelum ni. So, they already give us the value of mean, right? The value of mean already give to us, and the value of mode also provided. Tapi bukan provided percuma lah, you need to calculate, right? And the value of standard deviation also asked, right? So, in this case, to find the skewness value, you need to use mean minus mode divided by standard deviation. You no need to use the second formula, which is mean minus median. Sebab kita nak kena cari pula nilai median. We need to use whatever value that we have. And we need to remember, if you wrong this, you got the wrong answer for the first question and second question, the third question also will be wrong, even though your formula is correct, right? So you need to input the formula lah. Just plug in the formula. 17.05 minus the median, the mode is 16.78 divided by standard deviation 5.75. So what is the value? The value should be positive value, right? And the value is a positive value, kan? So, since the value is positive, but you need to write down the value lah. 17.05 minus 16.78 divided by 5.75 should be 0.0469, right? This is a positive value. Since this is a positive value, then we can say that, so nampak 3 markah, you kena interpret walaupun dia tak tanya. This is a skewed to the right distribution, right? Skewed to the right distribution. Okay. Now, the last question. A researcher has concluded the same study on machine Y, right? Dia kata kat sini, a researcher has concluded the same study on machine Y and obtained the coefficient of variation, time taken is 56%. Right. So dia maksudnya dia kata kat sini, coefficient of variation for Y is 56%. So determine which machine is more consistent in time taken to assemble computer component in motherboard. So now, kerja you senang, coefficient of variation, this is machine X, right? So standard deviation divided by mean multiply with 100%. So our standard deviation is 5.75 divided by 17.05 is our mean multiply with 100%. This one should be equal to 5.75 divided by 17.05 multiply with 100. It should be 33.72%. So, based on the comparison, coefficient of variation Y is larger than coefficient of variation X. So, we can say that distribution X is more consistent compared to distribution Y, right? And just to remind you, if you wrong the first question, second question wrong, question number 3, question number 4 will also wrong. So be careful on the first two questions. Right? Boleh? Ada soalan lagi? Ada soalan before we end our session? So on the next lecture, we will see more question, right? And we conclude the lecture lah, right? Okay. Tak apalah, if you have time, tengok balik example-example yang I bagi, right? It's the same concept. Benda yang senang, just ikut the formula sajalah, right? So if you have a question later on, you can ask me in the group. We'll try to answer lah. Okay? Boleh? So once you already learn this one, so try to go to past year question dalam library. Ambil tengok soalan number 1. Try buat semua. Sebab kita dah belajar. Chapter 1 dah habis. Right? We already look at chapter 1 dah habis semua. Right? Kita dah cover semua. Right, good. So next class we will do on probability and counting rule. But before next class, kita akan before masuk chapter 2, kita akan tengok sikit lah another example. Right? Next class kita tengok the first half an hour, kita akan tengok example past year question chapter 1. Okay? So before we go for next class, baca dulu, make sure you understand semua. Right? I think that's all. Thank you very much. Assalamualaikum.